Hi children, hope you are fine and safe. In the last class, we discussed about pressure exerted by liquids and gases. There we studied many points, that is, liquids always exerts pressure on the walls of their container because the liquids exist in its container. Okay, and the pressure exerted by water at the bottom of the container depends on the height of container. And what is the relation between the pressure and the depth? That is, as the depth increases, the pressure increases. As the depth decreases, as the pressure decreases. That is, we done a problem, that is, see where will be the pressure is high, at the bottom or at the base. It is at bottom of sea the pressure is high because as depth increases, the pressure increases. And we studied another point, that is liquid exerts equal pressure at the same depth. At the same depth, the liquid exerts equal pressure. And we also studied the pressure exerted by gases. That is, gases also exerts pressure on the walls of their container. Then we move on to the next topic, that is atmospheric pressure. This is our last topic of this chapter, force and pressure. What do you mean by atmospheric pressure? First, we have to study what is atmosphere. What do you mean by atmosphere? We all know in our surroundings there is air. Okay? In our surroundings there is air. That is, suppose this is the earth and earth. And surrounding this air, there is air. There is air here. Okay? There is air. All these parts contains air. And this place is called atmosphere. Then what is atmosphere? That is the part which consists of air above the earth is called atmosphere. So these are the atmosphere. Hope you understand. Then what is atmospheric pressure? That is, simply we can say that the pressure exerted by the air is called atmospheric pressure. Or otherwise we can say that the pressure exerted by the atmosphere. The pressure exerted by the air or atmosphere is called atmospheric pressure. Okay. The pressure exerted by the air is called atmospheric pressure. I already told you about the earth. There is air. We are existing this air in all around us. There is air, and this air exerts a pressure, and that pressure is called atmospheric pressure. Okay, the pressure exerted by the air is called atmospheric pressure. We already discussed about liquid pressure. That is, there is a liquid in this, and this is the liquid, and this liquid, here the liquid pressure is high. We all know here it is high pressure, and in the last class we discussed that is, as depth increases, the pressure is high. Here the pressure is high, and here the pressure is low. Here is low pressure. Why? Because here it is more water. The weight of water above this layer, above this part is high. The amount of water above this is this, and amount of water above this is very less. Here more water is lying above this part, and here less water is lying above this part. So the pressure is high here and the pressure is low here. And like that, this is the earth. This is the earth, and this is the atmosphere. Okay. This atmosphere can be classified into layers. That is, this atmosphere can be classified into different layers. That is like this. Okay, this layer is very far away from the earth and this layer is very near to the earth. Okay, here in this layer, we take this layer. Okay, the air above this layer is more. Am I right? The air above this part is more. That is, more air is here. And we take this part. Okay, this part. Then what is the amount of air in this part? Here, the comparing to this layer, comparing to this layer, there is less amount of air. We know there are many layers above and above, but by comparing this layer, there is above this layer there is less air. Okay, that is, it contains more air. So here the pressure is exerted by more air. So this layer has high pressure. And here only less air exerts pressure. On comparing this layer, only less air exerts pressure on this layer. So it has low pressure. So the part of the atmosphere which is nearer to the earth has high pressure and the part of the atmosphere which is far from the earth has low pressure. Okay, so how can we compare it with the height? As height increases, the pressure or the atmospheric pressure decreases. That is, from the earth, this layer or this part has less height and it has more pressure. It has high pressure. And this layer exists at a more height. So it has low pressure. So we can, here in this layer, it exists at a less height. So it has high pressure. Here this layer exists at a more height. This layer exists at a more height and it has less pressure. So here we can conclude that, here we can understand that the pressure is very low at a high height. Okay, the pressure is very low at a more height and the pressure is very high at a less height. Okay, so as the height increases, the pressure decreases. By comparing these two layers, which one has high pressure? This layer has low pressure and this layer has high pressure. By comparing these two layers, this layer has high pressure and this layer has low pressure. Hope you understand this. So we get the next point, that is, as the height increases, the pressure or the atmospheric pressure decreases. As the height increases, the atmospheric pressure decreases. Okay, then I take 2 points at the same height. That is, I am taking the 2 points at the same height. These 2 points are existing at the same height. These 2 points are existing at the same height from the earth. These 2 points has same height. Then what will be the pressure of these 2 points? That is, when we take 2 points at the same height from the earth, these 2 points exerts equal pressure or equal atmospheric pressure. Okay, so when we take 2 points, this is the another point, that is when we take 2 points at the same height, they will exert same pressure. Okay, here we discussed mainly 2 points, that is as the height increases the pressure decreases, and when we take 2 points at same height, the 2 points exert same pressure. At the same height, the points will have same pressure. Okay, then here you can see a picture on your textbook, that is pressure of atmosphere on your head. Here we calculated how much pressure is exerted on the head of this boy. That is, here the weight of air in a column of height of the atmosphere and area 15 centimeter into 15 centimeter is nearly equal to the weight of an object of mass 225 kilogram. Here we are calculating the pressure exerted in our head, that is the pressure exerted in our, how much pressure is exerted in our head. Okay, or the weight of air above our head, that is calculated here, and we get here it is 225 kilogram, that is 225 kilogram. You know, the pressure exerted on our head is calculated here, and the value is 225 kilogram. That is the weight of an object of mass 225 kilogram is existing above our head. Okay, that is the air above our head is exerting the pressure equivalent to the object of mass 225 kilogram. 225 kilogram is a big value, and the pressure equivalent to this weight is exerted on our head. I know what you must thinking. Why does not our head crest on this huge pressure? Here it is a huge pressure, you know, it is 225 kilogram, and why does not our head crest on this huge pressure? Why? Because we said that the pressure exerted by the points above the earth's surface is equal in all directions. In all directions, the pressure exerted by the points is equal. Here above the earth, here is the earth, and above the earth I take a point, and this point is exerts pressure on this direction, on this direction, on this direction, on this direction, and on this direction, on this direction. Okay, here this pressure is, here the pressure is exerted here when we take a point, and the air exerts pressure on all directions. So when this, here the pressure is exerted above, and here the pressure is exerted below, so these two pressures get cancelled. Suppose in tug of war we are pulling the rope, the two teams are pulling the rope in opposite sides. Here the pressure is equal, that is the team has same power, so net force will be cancelled. Similarly, here also the pressure, same pressure is applied on opposite direction, so they will be cancelled, and this will be cancelled, and this P also get cancelled. So here the net pressure, the total pressure or the net pressure is equal to 0. Here the total pressure is equal to 0. Okay. Like that, here also does not feel the weight 225 kilogram above our head. Okay. On balancing this pressure inside our body, a equal pressure is applied. Here there is 225 kilogram pressure is applied. 225 kilogram pressure is applied by the air, that is the atmospheric pressure. At the same time, from our inside the body there is 225 kilogram pressure is applied in opposite direction, so it will be cancelled each other. So we will not feel the pressure 225 kilogram in our body, because inside our body there is opposite, in opposite direction there is another pressure is applied from inside our body. Due to this, these two pressures gets cancelled, so our head does not crushed. Hope you understand. So we said that the pressure exerted by the points above the earth's surface is equal in all the direction. Okay. So the pressure exerted by air column at every point on our head is same in all direction. Okay. So hope you understand that why our head does not crushed due to this 225 kilogram pressure. Okay. Atmospheric pressure can be calculated by using a device, and that device is called barometer. The device used to measure atmospheric pressure is barometer. Okay, hope you understand that. That's all about our chapter force and pressure. Hope you understand the atmospheric pressure. The atmospheric pressure is the pressure exerted by the air, and this atmospheric pressure increases as the height decreases. When we take 2 points at same height from the earth, these 2 points exerts equal pressure. And we also discussed an activity in our textbook. Why does not our head crushed on the huge pressure 225 kilogram? That is, the pressure exerted by the points above the earth's surface is equal in all directions, so it is cancelled. So here the total pressure will be 0. These are all about the chapter force and pressure. In this chapter, we discussed about force. What is force? A push or pull is called force, and these forces are due to an interaction, and there is exploring forces. There are many points comes under these exploring forces, and a force can change the state of motion, that is state of rest, and the direction of motion, and the shape. The force can change the shape of an object. And we also studied the two types of forces, that is contact forces and non-contact forces. Muscular force and friction comes under the contact forces. Magnetic force, electrostatic force, and gravitational force comes under the non-contact force. And we discussed the pressure exerted by liquids and gases, and also the atmospheric pressure. Okay. And we also studied one equation in this chapter, that is pressure is equal to force by area. Okay, hope you understand all these things. You have to do the problems. You have to practice the problems related to the equation pressure is equal to force by area. Then in the next class, we will start our new chapter, that is friction. Okay, we will continue in the next class. Thank you.